Good morning everyone. This is Payavala Bhavagna from Institute of Aeronautical Engineering IARE. Today I am here to explain my topic from Essentials of Problem Solving AAT2. My topic is string compression. I am from Computer Science and Engineering section A and my roll number is 24951 A0559. Now let us get into the topic beginning with abstract. String compression is a critical technique in computer science aimed at reducing the size of textual data without losing information. By identifying and exploiting patterns within strings, compression algorithms improve storage efficiency and optimize data transmission across networks. Common methods include lossless techniques such as Huffman coding, run-length encoding, and dictionary-based schemes like Lempel-Ziv-Welch, which ensures the original string can be perfectly reconstructed. String compression finds applications in file storage, communication systems, and data-intensive fields like bioinformatics. Recent advancements integrate machine learning and probabilistic models to enhance compression ratio further, adapting dynamically to the structure of the input data. This paper reviews fundamental principles, popular algorithms, and modern innovations in string compression, highlighting both theoretical foundation and practical implementations. Now let us get into the introduction part. In today's data-driven world, the efficient storage and transmission of informations are more important than ever. String compression plays a crucial role in this context by reducing the size of text data without compromising its integrity. It involves the use of algorithms that detect and encode repeating patterns, sequences, or structures within a string to represent it more compactly. The primary goal is to minimize resource usage such as memory space and bandwidth, while ensuring that the original data can be accurately reconstructed upon decompression. Various compression techniques such as run-length encoding (RLE), Huffman encoding, and Lempel-Ziv-Welch, also known as LZW, have been developed over the years, each offering different advancement depending on the nature of the input data. Beyond traditional approaches, modern advancements are exploring adaptive and machine learning based methods to achieve higher compression rates. String compression finds widespread applications across numerous domains, including file systems, database management, web technologies, and even DNA sequence analysis. This study dwells into the fundamentals of string compressions, surveys existing methods, and examines recent trends and challenges, aiming to provide a comprehensive understanding of this essential field. Methodology. The methodology of string compression involves a systematic approach to reduce the size of the text data, maintaining the ability to fully reconstruct the original context. It can be broadly divided into several stages. Pattern identification. The first step is to analyze the input string to detect patterns such as repeated characteristics, substrings, and statistical frequencies of symbols. This analysis helps determine the most effective compression strategy. Performance evaluation. The efficiency of compression is evaluated based on factors like compression ratio, compressed size, original size, processing time, and resource usage. Testing is performed on various types of data to access the robustness and versatility of the method. Encoding. Once patterns are identified, encoding techniques are applied to represent the data more efficiently. Common encoding methods include run-length encoding. RLE encodes consecutive repeating characters as a single character and count. Huffman encoding builds a binary tree based on characters frequencies, assigning shorter codes to more frequent characters. Dictionary based compression uses a dynamic dictionary to replace recurring pattern with short code words. Compression execution. The selected algorithm processes the input string according to the chosen encoding scheme. Decompression strategy. Alongside compression, a corresponding decompression strategy must be established to ensure that the original string can be accurately reconstructed without loss of information. Now let us look at the code. which goes like with a variable define compress string, in the bracket we give input string, and then we use the if condition, if not input string, and we return, then compress brackets, and we give a count as 1 for I in range 1, length input string, if input string again I, which is equal to input string I minus 1. Count is given as 1, and in else statement we give compress append input string I minus 1 plus string count. We also add the string count in else condition, and we give the count as 1 again. Now after this we add the last character and its count. Compressed append input string minus 1 plus string count. Compressed string equals to join compressed. Return the compressed string only if it's smaller than original, and according to this condition we return compressed string if length compressed string is less than length input string, else input string. Example usage. So we give an input string as AAA, BBB, CCC, and again AAA, and compressed string equal to, we give the exact same statement which we gave in the beginning, that is compressed string equal to compressed string input string, and we give the print statement as original and F compressed. The output is supposed to give the number of repetition of alphabets, which is clearly seen here, that originally the input was AAA, BBB, CCC, and AAA, and when it is compressed it is written as A3, B3, C3, and A3, which is the count of the number of repetition of alphabets. Now let us look at some of the applications of string compression. File storage optimization. String compression reduces the size of text files, example documents, logs, resource codes, helping save disk space and improve storage efficiency. Data transmission over networks. Smaller data sizes mean faster transmission over networks, reduced bandwidth using, and lower communication costs, especially important for web data messaging and IoT devices. Database management. Compression techniques helps minimize the size of database records, enabling faster queries, lower storage costs, and improved overall performance. Web technologies. In web development, compressed data formats like compressed HTML, CSS, and JSON are used to speed up website loading times and enhance user experience. Few more applications are multimedia storage and streaming. String compression concepts are foundational to multimedia formats such as compressing subtitles, metadata, and even binary streams in audio and video files. Backup and archiving. Backup systems use compression to reduce the size of stored copies of files, making data archiving more efficient. Software and mobile applications. Applications often compress data to reduce app size, save user device storage, and enable faster downloads and updates. Cloud computing services. Cloud storage provides use compression to optimize storage space and reduce data transfer costs between several servers and clients. And lastly, bioinformatics. In genetic research, DNA and protein sequences, essentially long strings, are compressed for efficient storage and analysis. Now let us dive into conclusion. String compression is a fundamental technique in computer science that addresses the growing need for efficient data storage and transmission. By identifying and encoding patterns within text, compression algorithms significantly reduce data while preserving the ability to fully reconstruct the original information. Techniques like run-length encoding, Huffman encoding, and dictionary-based methods such as LZW demonstrate how structured approaches can optimize resource usage across a wide range of applications. From file system and web technologies to cloud computing and bioinformatics, As technology continues to evolve, modern compression methods are increasingly incorporating adaptive and machine learning strategies to achieve even greater efficiency. Ultimately, compression remains a vital tool for improving system performances, reducing costs, and enabling faster and more reliable data management. Now, these are few of the references from which string compression is extracted. Uh, Salmon D, Salomon D, and Mutta G from 2010. This is a handbook of data compression. Springer, a comprehensive guide covering traditional and modern compression techniques. This book covers traditional and modern compression techniques. A book called Introduction to Data Compression, 5th edition, written by Sayud K. And Morgan Kaufman, an accessible introduction to data compression concepts, algorithms, and applications. Huffman D. A. 1952, a method for construction of minimum redundancy codes, preceding of the IRE 1098 to 1101. Original paper introducing Huffman coding, a foundational string compression method. Ziv J. and Lempel A. 1977, a universal algorithms of sequential data compression. It states that IEEE transition on information theory. This is original work on the Lempel Ziv LZ77 algorithm, key to dictionary based compression. Few more references are written by I.H. Neil, R.M. and Clearly J.G. 1987. This comprehends the arithmetic coding for data compression, communications of ACM. This book demonstrates a detailed explanation of arithmetic coding, an advanced compression method. Another book called Data Compression Book, 2nd edition, written by Nelson M. and Gally J. in 1995, and it demonstrates practical examples and insights into implementing real-world compression programs. Thank you.